All right, welcome. Today, we're going to trace the absolutely fascinating evolution of the AI mind. We're going to see how AI went from, struggling to even remember a simple sentence to planning, strategizing, and actually taking action in the real world. It is an incredible story, so let's just dive right in.
I mean, think about that for a second. That is a huge leap, right? From just basic text prediction to an AI that can literally book your flights, find you a hotel, and build a whole itinerary. To really get how we got here, we have to go all the way back to the beginning, to this one fundamental problem that every AI had to solve: memory.
So, the first major hurdle was just figuring out how to make an AI understand sequential information. Things like sentences, where the order of the words means everything. This turned out to be a massive, massive memory bottleneck.
Now, one of the first really clever solutions to this was something called an LSTM, which stands for long short-term memory. You can think of it like an AI that reads a sentence the same way you do, just one word at a time, trying its absolute best to hold on to the meaning of all the words that came before. It was a big step forward, for sure, but it came with some pretty serious limitations.
See, because these LSTMs had to process everything word by word, they were just incredibly slow. But the real core problem was how they handled memory. Imagine trying to read an entire book and then cram all of its meaning into a single tiny sentence. That's kind of what LSTMs were trying to do. They compressed everything they'd read into this one little piece of memory. And as you can guess, over a long text, really crucial details from the beginning would just get lost. The AI would basically forget.
So the whole field needed a completely new way of thinking about this. And that breakthrough? It didn't come from making the one word at a time method better. It came from throwing that idea out completely and giving the AI a totally new way to see language. And this was the leap. We moved from that slow, sequential processing of LSTMs to a brand new architecture called the transformer. So instead of reading word by word, the transformer could look at the entire sentence all at once using a mechanism called attention. This meant it could process information in parallel, which made it unbelievably fast. But even more important, it could now understand the relationship between any two words in a text, no matter how far apart they were. That long-range memory problem, it was finally solved. This whole concept of attention is, well, it's everything. Think of it like this. When you read a sentence, your brain just instinctively knows which words are the most important for the overall meaning, right? Attention gave AI that same ability, to weigh the importance of every single word against every other word, all at the same time. This was the innovation that unlocked the massive power we see in AI today. It was a total game changer.
What's so cool is that this powerful transformer architecture was so flexible that it almost immediately split into two different specialized paths. You can think of them as two different children, each one having its own unique superpower. So on one side, you have GPT, the generator. Its whole job is to predict the very next word in a sentence. This makes it amazing at creative things like writing an email or maybe even a story. Then on the other side, you have BERT, the understander. Its job is to predict a missing word from the middle of a sentence, which forces it to understand context on a really deep level. This makes it perfect for things like search engines and sorting through text. Let's look at a quick example. GPT is autoregressive, which is just a fancy way of saying it looks at the past to predict the future. So you give it a phrase like, "The best thing about AI is," and it uses everything it knows to figure out the most likely next word, and then the next one, and the next one, building out the sentence piece by piece.
BERT, on the other hand, is bidirectional. It looks at the full context, both forwards and backwards. So by hiding or masking a word, we force it to use everything around that blank space. The thing about AI is its potential to figure out that the missing word has to be best. This gives it a much, much deeper understanding of how language actually works.
Okay, so now we have models that can generate and understand text incredibly well, but they've got another problem. All their knowledge is basically frozen in time, right? It's limited to whatever data they were trained on. So how do you give them access to up-to-the-minute information? Will you give them an external brain? This is where a technique called RAG comes in, or Retrieval Augmented Generation. Honestly, the best way to think about RAG is to imagine giving the AI an open book test. Instead of forcing the model to have every single fact in the world memorized, we just let it look up the relevant info from an external knowledge base before it has to answer your question. So how does that work in practice? Well, first, when you ask a question, the system understands what you're asking for.
Then it goes and searches a massive database, think Wikipedia or maybe a company's internal documents, for any relevant passages. It grabs or retrieves the most important facts and then hands them, along with your original question, over to the language model. And finally, the AI uses all this fresh, accurate info to generate a really well-informed answer. So we have models that understand language, and they can now access external knowledge. What happens when you combine all of that and give the AI the ability to actually act on that information? Well, that's the final piece of this puzzle, and it leads us directly to the rise of AI agents. An AI agent pulls together everything we've just talked about, and then adds one more crucial layer: action. It uses a powerful language model, like a GPT, as its reasoning engine. The goal is no longer just to answer a question, but to actually create a plan, use different tools, and execute that plan to achieve some complex goal out in the real world. So the core components are all here. The LLM acts as the brain. Then it's given a set of tools it can use, things like a web search, a calculator, or even the ability to write and run computer code. It has a memory to keep track of what it's already done, and a planning module to break a big, complicated goal down into small, manageable steps. And it all operates in this simple but really powerful loop. First, it thinks, okay, based on my goal, what's the very next logical step I should take? Then it acts, using one of its tools to do that step. After that, it observes the result. Did that web search get me what I need? Finally, it stores that result in its memory and just repeats the loop, getting one step closer to finishing the job with every single cycle. So there you have it. We went from LSTMs, which were just trying to solve basic memory, to transformers and that key idea of attention, which unlocked this ability to process huge amounts of data, which led to specialized models like GPT and BERT. Then we connected them to real-world knowledge with RAG, and finally we enabled them to act on their own with agents. It is just an incredible progression when you lay it all out like that. And that brings us right up to today and to one final, really fascinating question. For now, these agents are mostly following plans that we give them or breaking down goals that we set. But as we've just seen, the pace of this evolution is just staggering. So we have to ask, we have successfully built an AI that can follow a plan. What happens when it starts making its own?